Okay, Wildcats. Today we're looking at Wednesday, February 13th, rational function transformations on page 54. As you can see, this is the first assignment of the fifth 6 weeks. So if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. Rational function transformations on page 54. F of x equals negative a divided by parentheses negative bx minus h plus k, where the negative in front of the a reflects over the x-axis. When a is greater than 1, vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative reflects over the y-axis, it's in front of the b inside the parentheses. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. Minus h, it translates right. Plus k translates up. Minus k translates down. The asymptotes are vertical asymptote x equals h and horizontal asymptote y equals k. If you would, finish up your notes. All right, now your notes updated. Let's take a look at the examples. All right, now I've kind of added some lines throughout the problems to make the work a little bit neater. You can do that or you don't have to. Graph rational function transformations. Okay, now when we're graphing rational functions, we're going to put in the x values negative 1, 0, 1 into the function f of x equals 1 divided by x. Okay? So let's put in negative 1. So that's 1 divided by negative 1 equals negative 1. Okay? 1 divided by 0 is undefined. Okay, when x is 1, that's 1 divided by 1, which equals 1. Okay? So let's graph those points. So when x is negative 1, so negative 1, negative 1. And x is, now when x is 0 is undefined. So that means we have a vertical line, a dashed line, a black marker here so you can see it better. Okay, because when x equals 0, it's undefined. So x equals 0 is undefined. And when also in this case, y equals 0 is undefined. Okay, and then our next point is 1, 1. Now, the rational function is real simple. The graph borders the asymptotes. So once you know the point, you know that the curve is here. All right, now domain is from left to right. So it's negative infinity to 0, parentheses, or from 0 to infinity. That 0, the parentheses means it's not included at 0. Okay. Now the range is from bottom to top. So negative infinity. There's an asymptote at 0, so that's parentheses 0, or 0 to infinity. And that, so you understand that the asymptote's not included. All right, so the asymptotes are x equals 0 and y equals 0. And there are any transformations because this is the parent function. Now, if it's an x-intercept, f of x equals 0. Okay, so that means 0 equals 1 divided by x, and we need to solve for x. When you do that, cross multiply 0 times x is 0, 1 times 1 is 1, 0 does not equal 1, x disappears, so there are no x-intercepts. Now, if it's a y-intercept, the x equals 0. Okay, so now f of 0 equals 1 divided by 0, which we saw in the table is undefined. So there are none, there's no x-intercepts and no y-intercepts in the parent function. All right, let's take a look at example 2. All right, so we're going to graph by direction. Now, we know our directions are -1, -1, and 1, 1. Okay, so -1, -1, 1, 1. But here, we have to multiply by -1. So that's a +1, and that's a -1. Now we need to move our vertex, okay? So that tells us we go to the right 2. So 1, 2. Now, the vertex in this case is where the two asymptotes meet. So we have an asymptote at x equals 2 and y equals 0. There was no vertical transformation, so the y equals asymptote stayed at 0. Okay. Now we graph our points. So we go -1, 1, and 1, so I almost made a mistake. Because I was looking at the origin, but you have to move at the center of the asymptote. So here I go left 1, up 1 from the center of the asymptotes. Right 1, down 1. Now, once you know the dot, it tells you the curve is in this section. So it's curves here. And then once you know the point, again, you know the curves here. You only need 1 point. Once you know where the point is, then you know the curve of the function is in that section. All right, domain is from -infinity to, in this case, it went to +2 or 2 to infinity. And the range is -infinity to 0 or 0 to infinity. Now the transformations, again, doing from left to right. So the first one is reflect x-axis and right 2 units. All right, let's look at the x and y intercept. So if it's an x-intercept, f of x equals 0. So you set 0 equal, I'm going to put the negative in front of the 1, -1 divided by x minus 2. Divide that by 1, cross multiply. 0 times x minus 2 is 0. 1 times -1 is -1. They don't equal, x disappears, so there are no x-intercepts. All right, now for the y-intercept. If it's a y-intercept, x equals 0. So f of 0 equals negative 1 divided by 0 minus 2, which equals a positive 1/2. So your y-intercept is 0, 1 divided by 2. Okay, so finish up example 2. All right, let's take a look at example 3. All right, so we graph by direction. Now remember, our directions are negative 1, 1, 1. But here we have to multiply by 2. So that's negative 2 and positive 2. Now we need to move the vertices. So this tells us that we move left 1, but down 3. So left 1, down 1, 2, 3. So we have a asymptote at x equals negative 1, and an asymptote at y equals negative 3. So our asymptotes are x equals negative 1 and y equals negative 3. Now to graph, remember the center of the asymptote, so we go left 1, down 2, and there's this curve. Okay. And then we go to the right 1 up 2, and then there's this curve. All right, so our domain is negative infinity to, looks like negative 1, or negative 1 to infinity. And then the range would be negative infinity to negative 3, or negative 3 to infinity. All right, transformations. Looks like we have a vertical stretch of 2, left 1 unit, and down 3 units. All right, for the x-intercept, we know that we set f of x equal to 0. So 0 equals 2 divided by x plus 1 minus 3. So we're going to add 3 to both sides. You get 3 equals 2 divided by x plus 1. Divide that by 1. We cross multiply, so we get 3x plus 3 equals 2. We're going to subtract 3 from both sides. You get 3x equals negative 1. So x equals negative 1/3. So your x-intercept is negative 1/3, comma 0. All right, let's look at the y-intercept. When it's a y-intercept, x equals 0. So f of 0 equals 2 divided by 0 plus 1 minus 3. Well, that becomes 2 divided by 1 is 2. 2 minus 3 equals negative 1. So your y-intercept is 0, negative 1. All right, so finish up example 3. All right, let's take a look at example 4. Okay, remember, graphing by directions are -1, -1, 1, 1. But here, we're dividing by 2. So, you have -1/2 and 1/2. Okay, so we move the vertex, and it looks like here we go to the right 3, so 1, 2, 3. And then the y equals is just that y equals 0, didn't go up or down. So our asymptotes are x equals 3, y equals 0. So from here we go left 1 down 1/2, which is about right there. And then we go right 1 up 1/2, so we're here. All right, our transformations are vertical compression of 1/2 and right 3 units. All right, if it's an x-intercept, f of x equals 0. So you have 0 equals 1. I'm going to go and distribute. That's 2x minus 6. Put that divided by 1. Cross multiply. 0 times 2x minus 6 is 0. 1 times 1 is 1. They don't equal. So there are none x-intercepts. Now if it's a y-intercept, x equals 0. So f of 0 equals 1 divided by 2 times 0 minus 3, which equals 1 divided by -6. So our y-intercept is 0, comma, -1 divided by 6. All right, so if you would finish up example 4. All right, now your examples are finished up. Start working on your assignment and have a wonderful Wildcat